MeerKAT, originally the Karoo Array Telescope, is a radio telescope under construction in the northern Cape of South Africa. It will be the largest and most sensitive radio telescope in the southern hemisphere until the Square Kilometre Array is completed approximately in 2024. The telescope will be used for research into cosmic magnetism, galactic evolution, the large-scale structure of the cosmos, dark matter, and the nature of transient radio sources. It will also serve as a technology demonstrator for South Africa's bid to host the Square Kilometer Array. As of July 2016, only 1613.5-meter diameter dish antennae have been completed and are functioning, and the remainder is planned to be in service by 2017. Specifications: MeerKAT will consist of 64 dishes of 13.5 meters in diameter, each with an offset Gregorian configuration. An offset dish configuration has been chosen because its unblocked aperture provides uncompromised optical performance and sensitivity, excellent imaging quality, and good rejection of unwanted radio frequency interference from satellites and terrestrial transmitters. It also facilitates the installation of multiple receiver systems in the primary and secondary focal areas and is the reference design for the mid-band SCAR concept. MeerKAT supports a wide range of observing modes, including deep continuum polarization and spectral line imaging, pulsar timing, and transient searches. A range of standard data products are provided, including an imaging pipeline. A number of data spigots are also available to support user-provided instrumentation. Significant design and qualification efforts are planned to ensure high reliability to achieve low operational cost and high availability. MeerKAT's 64 dishes will be distributed over two components, a dense inner component containing 70% of the dishes. These are distributed in a two-dimensional fashion with a Gaussian UV distribution with a dispersion of 300 meters, a shortest baseline of 29 meters and a longest baseline of 1 kilometer. An outer component containing 30% of the dishes. These are also distributed in a two-dimensional Gaussian UV distribution with a dispersion of 2,500 meters and a longest baseline of 8 kilometers. For Phase 2, 7 additional antennas will be added to extend the longest baselines to about 20 kilometers. Construction schedule. To acquire experience in the construction of interferometric telescopes, members of the Karoo Array Telescope constructed the phased experimental demonstrator at the South African Astronomical Observatory in Cape Town between 2005 and 2007. During 2007, the 15 meters experimental development model telescope was built at the Karoo Radio Astronomy Observatory to serve as a test bed for MeerKAT. Construction of the MeerKAT precursor array on the site started in August 2009. In April 2010, 4 of the 7 first dishes were linked together as an integrated system to produce its first interferometric image of an astronomical object. In December 2010, there was a successful detection of very long baseline interferometry fringes between the Karoo Radio Astronomy Observatory 26 meters dish and one of the KAT's 7 dishes. Despite original plans to complete MeerKAT by 2012, construction was suspended in late 2010 due to budget restructure. Science Minister Naledi Pandor denied the suspension marked any setback to the SCAR project or external considerations. MeerKAT construction received no funding in 2010-11 and 2011-12. The 2012 South African national budget projected that just 15 MeerKAT antennas would be completed by 2015. The last of the reinforced concrete foundations for the MeerKAT antennas was completed on the 11th of February 2014. Almost 5,000 square meters of concrete and over 570 tons of steel were used to build the 64 bases over a 9-month period. MeerKAT will be completed in 3 phases. The commissioning of MeerKAT 2 take place in 2014 and 2015, with the array coming online for science operations in 2016. This phase will include all the antennas, but only the first receiver will be fitted. A processing bandwidth of 750 MHz is available for the second and third phases. The remaining 2 receivers will be fitted and the processing bandwidth will be increased to at least 2 GHz, with a goal of 4 GHz. Science objectives. The science objectives of the MeerKAT surveys are in line with the prime science drivers for the first phase of the SCAR, confirming MeerKAT's designation as an SCAR precursor instrument. 5 years of observing time on MeerKAT have been allocated to leading astronomers who have applied for time to do research. MeerKAT will also participate in global VLBI operations with all major radio astronomy observatories around the world, and will add considerably to the sensitivity of the global VLBI network. Further potential science objectives for MeerKAT are to participate in the search for extraterrestrial intelligence and collaborate with NASA on downloading information from space probes.